Try to quickly go through some of the other projects that were in the other articles that were in the AD. I'm going to go through 6 projects just to give you an overview of the other types of research that some other offices have been doing. So as you all know, the title of the issue is Experimental Green Strategies, Redefining Ecological Design Research. And I chose 6 projects to go through that look at questions of how can a building modify climate? How can we use performance feedback and make adaptive and responsive buildings? And what are key parameters for sustainability? So some of these questions have, of course, also been addressed in the other presentations today. The first project that I'm going to show you is the Sony Research and Development Center in Tokyo, and it's by Nikken Sekkei Architects. And it's also with their research group, which is the Nikken Sekkei Research Institute. And it's a separate research and development group that consults on all of their projects. And it has 65 designers. So it's a big research group. And Nikken Sekkei Architects are one of the biggest architecture offices in the world. I'm sure you've probably seen some of their buildings. So the question of how can a building actually modify the surrounding climate? This is the project. It was finished in 2011, and it's an interesting client for a innovative project because it's actually their research and development group. So they were very open to trying new things and experimenting with new strategies. And this is a view from inside the building. And they designed this urban cooling facade, which is what you can see, of course, in large scale right here. And it was the main research question was how to combat the urban heat island effect, which has been raising Tokyo's annual average temperature by 3 degrees. So it's quite a serious environmental problem, and so they were actually trying to design a building that would begin to combat that, and the goal was to decrease by 2 degrees the air surrounding the building. The research group, the Nikken Sekkei Research Institute, typically they begin by a strategy of planting vegetation on and around the building, because that's quite an effective way of lowering the temperature surrounding the building. But in this case, the site, it wasn't possible to do that because of the siting and also the tight urban site. So they had an idea to evaporate rainwater from inside porous ceramic tubes. And so they designed a louver facade system that functions as a sunshade in the morning and handrails on the northeast facade, which you can see here. And and then they monitor it using a system of environmental sensors to monitor the performance. So they did a study of the water cycle in the city and thought, how can they translate some of these concepts into the facade of the building? And so they gather rainwater on the rooftop, store it in the bottom, and then pump it through the facade. That's a general strategy. And so you can actually see the ceramic porous tubes on the just inside the glass, and you can see the rainwater drainage pipes. And in the image, you can see the 2 layers of the building. And so they did a series of mock-ups and studies of how you actually develop a material that will perform in this way and also have architectural quality. So to embed the performance and the function also with the architecture. And it's a massive application of this bioskin. So it's quite an exciting project, and they have plans to measure it once it's been in use to see how to see if they were able to decrease it by 2 degrees. And another project which deals with this question of modifying exterior climate is By10 Design, which is an architecture office in China, when they worked with researchers from Hong Kong University. And it was on a research project called Indigo Tower. And the idea behind it was how to create a facade that actually cleanses the air around it, because air pollution was a concern that they wanted to address at a building scale. So it's an ambitious project, and in the article that they wrote about their ideas for the project, they called it Beyond Neutrality. So they're actually trying to improve the environment around the building, as well as the environment inside the building, of course. So they were trying to ask the question of how can a facade actually improve the air quality of the city? So the Hong Kong University researchers that they worked with have ongoing research into biopurification. And so they tried to devise a strategy that used passive solar and nanotechnology. And the idea is to create a cleansing reaction that uses a nano coating of titanium dioxide from the outer skin, which needs light to begin to pull in grease and dirt and bacteria from the air. And then photovoltaic panels on the facade power a series of UV lights to begin this oxidization process. And then they have various strategies to stop light from going inside the building, but while still providing this sort of glowing tower on the outside of the building, which they see as symbolic of this cleansing process. And they used a lot of different strategies for simulating, measuring, and modeling their design during the design process. So it's basically 3 towers that they imagined here that are connected. And they did a series of simulations and measurements in terms of air pressure and air velocity. And they did many studies on wind pressure because they designed high-level balconies that needed to be sheltered, and they were looking at cross-ventilation for air quality inside the flats and wind speeds on the facade to heighten the cleansing reaction. So they went into quite a bit of detail in the article, so I recommend you have a look. The wind pressure distribution diagram, they had this idea where they wanted to circulate air through and around the building, but they didn't want the used air to come back into the balconies and cross-ventilation of the units below it or above it. So they had this strategy of pushing the used air away from the building while still allowing fresh air into the building. And yeah, they studied the form, trying to incorporate the cleansing reaction and the performance into the form of the building. And a slightly different project, a different research question, is how can you use performance feedback to make adaptive and responsive buildings? That's something we've talked about today in some of the other projects. And this is a project that's by the Adaptive Building Initiative, which is a collaboration between Hoberman Associates and Bureau Happold. So they went into detail in their article about how they work together and how they share knowledge, but also in specifically to this one project, which is called Tessellate, which is an adaptive facade. And I think I have a video. Maybe it's after this. I'll just explain. It's the Adaptive Building Initiative is a multi-project collaboration about adaptive building components. And in this case, the shading coverage is relative to the sun position, and they used ray tracing simulations to tune the building's performance. And their goal was to design technology and design as one dynamic system. And this is, you hear often about adaptive buildings, but this one, their ambition was to create actually a real-time, dynamically controlled or pre-programmed behavior. So when I was talking to them about this project, they were saying that when the sun or when the clouds pass over the building, they want the building to actually react. So they want real-time interaction with climate, which I think you'll see. Hopefully in the video. I would have to say not. We'll go on to the next one. The next project is by 2012 Architecten, which is an office in the Netherlands. And they have a very interesting way of representing their designs and representing their ecological design strategies using something called harvest mapping. And so they were asking, what are key parameters for sustainability? And their strategy is to map materials, energy, flows of capital, resources in and out of the site, and looking at learning from industrial ecology in representing these strategies in new ways. So this is an example of one of their harvest maps. So when they start an architecture project, they put the site on the map, and then they map outwards from it. What kind of resources are on the site? What kind of climate is it? What kind of physical resources in terms of who lives around the area? What expertise do they have? What kind of facilities are there that could be recycled, or what kind of materials are no longer being used? And so at the bottom, for example, there's an example showing they found some glass that could be recycled. And so they thought, well, how can we incorporate that? It looks like just garbage, a bunch of broken glass. How can we use that? It's a free resource, it's on the site. Another example is there was a disused cable reels being stored near the site. And so they actually took them, dismantled them, reused them, and they claim that this recycled timber facade uses 5% of the CO2 that a new facade would have used, including production, preservation, and transport. I don't know how they calculated that, but it's a very interesting way of thinking about recycling on a different scale. And it's actually quite a beautiful building, and it's very modern inside. So it's a very interesting example of recycling at component scale, and they also look at recycling on an urban scale if you think about using resources and materials that are already on the site. Another example is they used steel profiles from a disused textile factory. And so with just one textile machine, they provided enough steel for the entire structure. And it's interesting that their initial design footprint had to be adapted to be 10 centimeters narrower to use these found materials. And this is the project. And it's also interesting how they represent their projects. So they've borrowed ideas of representation and conceptual ideas from industrial ecology and working with flows of water, food, energy, and capital on the site. And they've also developed an online system modeling tool to share research and thinking about different ways you can connect data and have it be involved in the ecology of a project. They also use these Sankey diagrams, which are a special way of showing information where the size of the arrow actually shows the increased or decreased flows on the site. And they do these kinds of drawings for projects even like houses, small schools, like quite small scale buildings. They put a lot of research and a lot of different techniques of representation. And they also have this great website called Superuse, where they try to document and share all of these information of different recycling things that are out there, different local sources, different strategies. Some of them are more interesting than others, but it's definitely an inspiration. It's superuse.org. And I think the last project that I'm going to show you is a Rao Architects project. They're a Dutch office that are known for their nearly zero energy buildings. And I interviewed them for the AD, and I spent quite a lot of time talking to them about how they see new parameters for sustainability, what they think the future concerns will be, sort of forecasting what's next. And they have a new project called Turn 2, which is quite a bit different than a normal architectural project. They're actually trying to develop a new model for consumption and a new way that people use buildings. They're quite well known for projects like this. This is a CO2 neutral renovation to the World Wildlife Foundation in the Netherlands. And this was published quite a lot. It's a very interesting project that uses a lot of different techniques that are detailed in the article. One of the stories that he told me was that they actually designed a bat basement, so a place for bats to live just down there. So I think if I actually visited that building in real life, I would be listening for bat behavior. But there's a lot of different techniques, and it's basically a test of how do you renovate to a CO2 neutral standard, which is very ambitious. And they've done a series of schools, or a series of projects that are actually at design stage assessed as CO2 neutral and actually plus energy. So this project here is actually the first plus energy school in the country. So talking to Thomas Rau, he really believes that the energy problem can be solved if there's enough will and enough money and enough research put into a project. He says that's something that we can solve as designers. But what we can't solve is raw materials, is what happens when we actually run out of raw materials. And he's formed he has a collaborative research institute called One Planet Architecture, looking at sort of these ideas and what we could do with as new strategies for recycling at different scales, for design for disassembly. And that comes to his turn 2 concept, which it's this new strategy of that what if you didn't actually buy components to buildings? What if, for example, you could rent facades? What if you could just pay for performance instead of for products? And I think it's just such a great idea. And I think it could really be something that people really, could be cheaper for consumers, could be better for designers, could promote innovation by manufacturers. And he's testing this idea in his own office. And this is the interior of his office in the Netherlands. And he's started this project where he's actually working directly with manufacturers, such as Philips for lighting, Steelcase for furniture, Deso for flooring, Plugwise for energy monitoring. And the idea is that he's not paying for lights, he's paying for light. So he's paying per lux. So that's a completely different way of thinking about performance. He says he doesn't want to be bothered owning the floor. When he's finished with it, he wants them to come and collect it, take it away, do whatever they do to it, strip it apart, keep the bits they can keep, recycle it. But he doesn't think that consumers should actually be responsible for the end of life of components. So I think it would promote innovation by manufacturers, because if they want to make more money, they could make something that could be stripped apart, reused, sort of cradle to cradle type principles. And so he's tested it in his own office. And from Azam's image this morning of the Earth, reminding us all that it's a system that we're working within and an ecology, I think I'll leave it on that note and let us have a discussion with all of the speakers from this session. That would be great if you could come up here. Thank you. Okay.
1, 2, 1, 2.
Well, thank you very much for fascinating presentations. I was thinking that quite a few of the things that we discussed this morning came back in a different way. I thought it was very exciting to see how in practice so much attention is now paid to the detailing of the design. And even more so, because in the morning I was lamenting at the lack of real data, and at the fact that architects and engineers don't seem to be going back to their buildings to study them. And so I was very pleased to hear that all of you seem to be going back to the buildings to study them. And in case you needed help, I have about 40 possible helpers here, each one of them starting a dissertation project for a Master of Science or Master of Architecture. And we are not selective about climates because they come from 30 different countries, most inhabitable climates, both north and southern hemisphere. So you have buildings to offer, we can take them. Now, well, let's see if there are some questions or comments from the audience. I think we didn't have enough time in the morning to comment on all of these.
It's very interesting for me to actually come back and see from maybe a little bit from Simos, viewpoint. Maybe a little bit from the viewpoint of, I think it's okay. A little bit from the viewpoint of Simos, I think. Maybe so I was wondering, like about few years, maybe 5 years back, and Simos has been critical in this, kind of pushing the agenda of architects, taking a role in analysis and performance, of buildings. And then there was a very interesting presentation today by Meredith, who was on the other side, engineer kind of looking at it. And then it was very nice that Hugh came in and, mentioned a few things. That we really need specialists, right? We need expertise, of a very high degree. So in that perspective, is the new agenda, Simos, which you need to kind of tackle changing? Because we've kind of accepted the fact that architects will analyze. Simulation analysis is becoming rather common. Everybody is going to simulate now. So is it shifting to the quality, or is it shifting to a different level of collaboration? What do you guys think?
You want me to answer?
Certainly you, because I think you're critical in pushing this architects analyzing agenda.
I think in the morning it came up as an observation that I put forward, that using simulation is actually learning about the principles, and similarly going to real buildings and observing how they work and talking to people who inhabit them and finding out how they use the buildings. All this becomes quite instructive, and at the end it could well be that we become like all type architects, that we have experience, and hopefully perhaps that this experience, experiential sort of appreciation of buildings, can be as helpful as simulation. I think it was a point made by one of the speakers very recently, Giovanni, yeah, that precisely that how do you know that simulation is right? And well, precisely, especially if it is that you're going to spend a lot of time and perhaps money somehow to get the results. You can only know it's right by having some experience from before. And when you do have very strong experience from before and you're not innovating at that moment, I'll come back to, I know that you want to innovate each time, but if there is no major innovation of the sense that performance will be affected dramatically, then you no longer depend on simulation. So I think it's both good to be able to do it and to have done it as a learning process and to be able to go beyond it. But let's see, anyone else? Or
I could add a small point to that, perhaps, that in the end, a simulation, a model will always, a computer will always answer questions that you have asked. It will not, it will very rarely, unless you set it up willfully to tell you unexpected things, it will only tell you in a way what you already suspect much of the time. And the reason why we insist on going back and learning from the buildings, because every time we go, we find out things that we would have never expected. And in that sense, reality is a better teacher. Although simulations are incredibly useful, and they often do tell you some unexpected things, but mostly they help you visualize things that you already have hunches about. That's my... and it definitely helps speed it up. But you know, all these years of doing modeling, and in the last few years, I've come to find that actually it's really all about people. And that's where we really need to focus a bit more.
So is the gap between...
So you're talking about some retrospective sort of calibration of your simulation process. Is that because the way you idealize the design to put it into the simulation software was inadequate, or was the building built differently to the way you